and also for giving me the opportunity to talk to you today for the Flood and Coastal Risk Management Network. Hopefully the technology will work for us to get through this. Okay, now today I want to talk about recent storms that we experienced during the last couple of months, and the response of our shorelines to the frequent storms we had. The outline of my talk today is that I'll first give you an introduction, just putting this problem of coastal erosion and flooding into perspective, and then I would like to talk a little bit about the recent storms we had and coastal erosion and flooding associated with that. And then I want to talk about the impact of frequent storms, which was quite unusual this winter. We had storm after storm coming on our way. And then I'll talk about a study we did to quantify the impact of frequent storms, not in the UK though, but just the same process, and so I'll talk a little bit about it. And then the FloodMEMOry Project, in which we are looking at the same process and the impact on the coastal zone. With that, I'll wrap up. Okay, putting this coastal erosion and flood problem into perspective, 2.5 million properties in England and Wales are at risk of river and coastal flooding, and also 20% of properties in Scotland alone are at risk of coastal flooding. So you could see the scale of the problem. In addition to flooding, a significant portion of UK coastlines are eroding from north to south, from east to west. You can find many coastlines around the UK which are eroding at the minute. And DEFRA and Environmental Agency had estimated that approximately 700 properties in England are vulnerable to or at risk of coastal erosion. And by 2030, there'll be another 2,000 adding into it. And with all that, many coastal communities rely on beaches and sand dunes as their primary defense against coastal erosion and flooding. So you could see the problem of erosion and flooding, how it affects communities and the system themselves, and also the communities. Okay. So, talking about recent storms, coastal erosion and flooding, you have seen it all and everywhere in the country from last December until February. Even now, it is happening. There are various problems everywhere. So here is the Norfolk during the December 2013 surge, and here what you see is the coastal flooding in southwest. And the left-hand figure below is Newquay, a broken promenade and the seawall, and then the right-hand side figure below it shows Aberystwyth, which was hammered storm after storm during the last couple of months, created a lot of coastal flooding and damage. A little bit closer to home in Swansea, we have a very nice sand dune system in the Swansea Bay. What you see here in the top figure is the dune system in the bay, in the east side of the bay, and what you see below is the dune system of the storm. So the dune system was wiped out completely in some part of the bay. And also, if you look at the figure, right-hand side figure, the top figure, again an eroded dune system. Behind this, what you see is a children's play zone, play area, which is now looks more like a war zone after all these storms that occurred. And the right-hand side figure, the figure below, you can see that I had marked the spring tide level in the red broken line. That is the spring tide level in February 2014. But if you look at the dune system behind it, you can see that the dune system is about 50-60 feet away from the high tide level. The surge reached the dune system here during the storms and eroded most of it. So you could see the scale of the problem everywhere. Now going a bit south in Dawlish, much talked rail line and the failure of the seawall. And you could see the picture. You have seen. I'm sure you have seen most of these pictures before, because it was all over the news and media. And you could see a picture during the storm and then what happened after the storm. So, talking a bit about what happened in Dawlish and what sort of events led into that situation where the seawall was damaged and the rail line was broken. Now, this is a measured wave record at Dawlish, measured by the Channel Coastal Observatory in January to February 2014. The red square shows you the event that led to the failure of the seawall. You could see that the wave heights reached 6 meter mark almost, and the waves coming from the south-southwest direction. And looking at the wind field, you could see again the red cage is where the failure occurred. We had wind reaching 20 knots that day. And then if you look at the atmospheric depression and the surge we had the same day, I'm afraid the x-axis, the timeline is not the same in both figures, but the red square shows you where the storm was. So you could see that the surge was about a meter, half a meter to meter, and so this exceptional surge and also the storm waves led to the failure of the seawall on the 5th of February 2014. So that was the result. Okay, now talking a bit about the storm the storm that occurred that particular day, and also the impact of frequent storms. Now, if we go back to look at the records of wave heights at Dawlish, the waves of 5 to 6 meters is not at all very uncommon. I mean, if you look at this wave record here, which was taken in 2012 April, you could see that the maximum wave heights reached 5 meter mark, or even beyond 5 meters. So it's not an exceptional wave height. And also, if you look at the surge that this day on April 2012, you could see just about half a meter. Or even higher than that surge occurred that day. So you could see that it is, well, I'm not sort of undermining the severity of the event that occurred that day, but it is not unusual to have high wave heights and also significant surges in the area. But then, if you look at the statistics, you could see that average wave heights are, of course, quite low, and these statistics were calculated using 5-year records of wave data. So the monthly statistics show that we can have, quite significant wave heights in the area, and the waves are reaching more or less from the same direction, south to southwest. And but the most important thing, or something different which didn't have had happened before, is that if you go back to the same wave record where the damage, during the period where the damage occurred, you could see that the arrow shows where the day where the damage occurred to the seawall. And prior to that, this red horizontal line shows the sort of storm threshold defined by the Channel Coastal Observatory. And you could see that there are 5 other events prior to this large event where the wave heights exceeded the storm threshold value. So you could see we had a sequence of very large storms occurring within a very short time, from 16th January up to 5th of February. Now, so that sort of tells us there is something going on apart from the waves and surges, and it may be that the frequent storms reduce the resilience of beach systems to coastal erosion and flooding. So that is what we are investigating. Now, long before this series of storms coming on our way to UK, we did a study on the same sort of thing to look at what frequent storms can do to our shorelines. We did a study based in Narrabeen beach in Australia. Actually, the beach system you could see here, it is subjected to very different conditions from what we have here in the UK. Those beaches are subjected to very frequent storms all year round. They have various different weather systems, tropical, subtropical, depressions, northeasterlies, and all that, creating a lot of storms. So we went in to compile a 20-year record of storm conditions in this area in the east coast of Australia, and found out that on average about 20 storms come every year into this region. And then we went in to look at storm clustering and the impact of storm clustering on this particular beach. And actually, when we talk about storm clustering, it's a bit subjective, because the frequent storms or clusters of storms, the definition of that depends on the locality, really. In this particular case, in Narrabeen Beach, we took that if the two storms occur at sort of less than 9 days interval, we call it as a storm cluster. And also we considered that if the wave height exceeds 3-meter mark and remains higher than 3 meters for 1 hour, it is a storm. So that is the definition of a storm and a storm cluster. So based on that, we went into to compile all the storm clusters that occurred in the Narrabeen area from 1981 to 2001. And then here what you see in this figure is the some of the clusters that occurred in the area. And then we looked at how the beach responded to the clusters of storms. So in the left-hand side, you could see some clusters, and in the right-hand side, the corresponding storm-induced, storm cluster-induced, I would say, beach erosion. So you could see that quite a bit of beach lowering and erosion had taken place in the area. Now, with that, by compiling all the storm clusters and all the pre- and post-storm profiles we had, we went in to calculate beach erosion from clusters as well as from individual storms. And here, what we have drawn is the erosion volume against what we call storm power, the index that we use to define a storm. Now, if you look at it, storm power is the function of wave height as well as the function of significant wave height of the storm as well as the duration of the storm. So, because we found out that the storm duration is also important when we talk about the severity or the strength of the storm. Now, what you can see in these two figures is that the first figure related to individual storms, and the second figure, the right-hand side figure, represent storm clusters with two or more storms in a cluster. Now, we calculated the storm power for each individual storm, and then the total storm power, that is the summation of all storm powers of individual storms in the cluster. So now, if you look at these red lines here, you could see that for individual storms, for example, if you have the storm power of 4,000, the erosion volume, beach erosion volume, is around 40 cubics per meter of beach width. And if you look at a cluster with same storm power, the total storm power, the erosion levels is almost double that of the individual waves. But in this case, you can see that this is the total storm power. So the power of each individual storm in the cluster is much less than the power of the individual storm in what you can see in the left-hand side. So you could see that storm clusters can have significant impact on beach erosion, and which can lead to coastal flooding as well. And with that, now I want to talk a little bit of the FloodMEMOry project. I'm sure most of you have heard about it. This is an EPSRC funded project, which was funded by the Flood and Coastal Erosion Risk Management Sandpit we had in 2012. And the overall aim of this project is to investigate the effects of temporal clustering of flood events on natural, built and socio-economic systems with memory. The memory, the word memory here applies to the situation where, okay, you have one flood event, and then the next or consequent flood event happened before the system recovers from the effects of the previous event. So that is the idea of the memory here. Now, in relation to coastline, what we do in Swansea is that we model impacts of temporal clustering on storms and surges and the role of memory of coastal systems in reducing their resilience to coastal flooding and erosion. Now, what we do in this is we selected the case study area, Sefton Coast in Liverpool Bay. In the left-hand side, you could see the Sefton Beach. And it is a very dynamic and a rich beach system. You can see quite a lot of sand dunes and also some defended areas with sea walls. And we are mainly focusing on the sand dune system. Actually, the sand dune system in Sefton represents a significant portion of sand dunes in the UK. So we look at the sand dune area. We went into model the morphodynamics in this area to look at the impact of storms and storm clustering. Using a combined set of models, a cascade of models, we set up the 3D Swan and X Beach together to look at the dynamics, waves, and morphodynamics. And then we will use this modeling system to look at beach erosion, wave overtopping, and coastal flooding. Now, we had calibrated and validated our models against the various existing measurements we had. And here is a model calibration and calibration against a storm that occurred in 2010. So the pre and post storm profiles were measured, had been measured during another project. So we used those profiles to validate and calibrate our models here. And then we use the validated model to look at the existing morphodynamic system in the area, to look at what is happening with sand dunes, how they respond to wave conditions, and also a little bit beyond the intertidal area as well. So to understand what's happening now. And then the next step, the model is already, so we are now in a position to apply the modeling to look at what happened to the dune system during the winter storms in December 2013 and February 2014. So we have all the wave data. We had gathered all information about waves, wave heights, periods, and directions. And then we had wind speeds. You can see the depressions during that time in December, from December to February 2014 here. Drive lots of very significant wind velocities. And then we had gathered all the water level information with the surge. So you could see that the surge in some cases, in some days, exceeded 1.5 mark, which is quite significant. So the next step for us is to run the model for this storm system, and then look at the response of the dune system into this cluster of storms. Okay, with that, now before I wrap up, actually, I want to thank Dr. Doug Pender, who tirelessly worked on Narrabeen beach system, looking at storm response and impact of storms. And then Dr. Pushpa Dissanayake, who is working on the FloodMEMOry project and had done a lot of work making, calibrating, validating models and setting up the model to study the impact of storm clusters. Now, coming into conclusions now, combined storm waves and surge is mostly responsible for coastal erosion and flooding. But frequent storm occurrence weakens natural beaches and man-made sea defenses, thus exposing them into greater risk. And also, chronology and interval between storms in a storm cluster can have significant effect, as we saw from the Narrabeen study on the resilience of beach to storm attack. And then within this EPSRC-funded FloodMEMOry project, we aim towards quantifying the effects of storm clusters on resilience of flood and coastal erosion systems. Thank you very much. I'm quite happy to answer any of the questions you have within the 10 minutes time frame we have. Thank you. I have one question from JBA Risk Management. Having quantified the impact of storm clusters, how will you apply the resulting information? Okay. Well, if you know what happens with the clusters, actually, that is exactly what we are trying to do within the FloodMEMOry project. The idea of the FloodMEMOry project is that not only to look at past storm systems but future conditions as well. What we do here is that we take all the historic information, 30-40 years of wave data and water level data, and then use super statistical techniques to look at clustering, to identify the historical clustering events. And taking this information, we go into predict future clustering using some statistical techniques, and then you do Monte Carlo simulations of future clustering events. And then we will be able to simulate beach erosion and flooding from various scenarios of storm clustering, and then look at a long-term statistical framework to tell us, okay, the probability levels of occurring, the levels of certain clusters occurring, and also the resulting coastal erosion and flooding, which will be useful to define uncertainty and risk levels of flooding and erosion. I suppose I answered your question. I have another question from Ben. In the grand scheme of things, how have the recent storm events impacted upon coastal erosion compared to previous years? Also, I would test, would I test case in the southwest for Wales be more appropriate to look at this compared to Sefton? Of course, I mean, we are quite interested in, well, to answer your first question first, okay. Well, if you look at the history of Dawlish seawall there, and also the train line, there are numerous previous occasions where some damage had occurred to the seawall and also to the train line. So it is not sort of uncommon story here, but the magnitude and scale of damage from this particular storms is enormous, and you know, there were repairs needed to be done at previous occasions, and the history of problems with the seawall because it is right at the you know, the train line is right on the seafront. But this event is quite exceptional. The recent event is quite exceptional actually. Well, your question regarding using the southwest of Wales compared to Sefton, yes, the issue we had at the time of writing this proposal is to have enough data to do this kind of assessment. I mean, southwest, of course, obviously is the better candidate than Sefton in terms of the wave conditions and wave approach, but unfortunately, you know, we didn't have enough information to work on that at the time. Especially, we need quite a bit of measured bathymetries and also various other information. So that is one of the reasons that we selected Sefton Coast at the time of writing the proposal. But we are quite interested now to look at what happened. I mean, model the situation in Dawlish as well. We are working on it to see if we can sort of repeat the same thing we've done in Narrabeen in Dawlish as well. And also at a later stage, we'll try and model Dawlish and also some southwest beaches which were significantly affected by the storm system in winter. Thank you. In fact, we have only 1 minute now, so if you don't have any more questions, perhaps we'll make it a close. Thank you very much. Thank you.